All right, everybody. Right now, we're going to talk about the queue interface. We're going to talk about queues. Last time we talked about lists. We're going to talk about first in, first out processing. We're going to compare linked list versus priority queue. We're going to talk about their core methods. What is a queue? A queue is a collection designed to hold elements prior to processing. It works on a first in, first out. So an element is inserted to the back of the queue, comes out through the front of the queue. It models a line of work waiting to be handled. So any kind of assembly line type of work, such as printer jobs, support tickets, task execution, message processing. So in the first in, first out behavior, as one can see here, items enter at the back and leave at the front. Processing order matters more than storage order. So this is the difference between a queue and a list. Lists, their primary job is to store data. So you store the data, access the data, perform operations on the data. Queues, on the other hand, they're more interested in processing the data than storing the data. When do we use queues? We use them for sequential task processing, request handling, and buffering. So we take these requests, we put them in a queue, and process them accordingly. Producer-consumer communication. So we have producers who add to a queue, and then there's a consumer which takes from the queue. And this is regulated depending on whether the queue is at capacity or not. Event handling and scheduling, as well as algorithms. Let's talk about linked list as a queue. It has the standard first in, first out behavior. As I've already mentioned, when talking about lists, it's backed by doubly linked list. So basically these nodes that have forward and backward pointers. And linked lists are best for task processing and buffering systems. Now let's talk about priority queue. So priority queue is a little different. It's not strictly first in, first out. So yes, elements do enter through the rear and come out through the front. However, those elements are prioritized. So the highest priority element is always removed first. Internally, this is backed by a binary heap, so it's backed by a tree. And one may wonder, what do you mean? And honestly, it took me a while to understand what it means. So essentially, here's this binary heap. It's a tree. And what this tree does is it always keeps track of the highest priority element. So this is a parent node. The child nodes always have a greater value than the parent node. So the root node is always going to be the highest priority element. So in this way, whichever is the root node is the highest priority element. And this is how a priority queue works. It uses this mechanism to find the highest priority element. Okay, back to the task at hand. So priority queues are best for scheduling simulations and priority tasks. So a good example is emergency room triage. So in emergency room triage, you take care of the most critical patients first, and then the ones with less severe injuries later. So here's a visual demonstration of linked list versus priority queue. So the queue would represent the linked list. Okay, and look at the movement. So in priority queue, for example, the elements are prioritized as they're inserted into the queue. So if you're watching this presentation, feel free to stop this for a moment and take a look. So we're back to our table. So let's take a look at LinkedList and PriorityQueue. So these both implement the queue interface. And LinkedList, as we've already mentioned, also implements the list interface. LinkedList is ordered based on insertion. PriorityQueue, not so much. It's more of which element is the highest priority. These both allow for duplicates. Linked list is not sorted, but PriorityQueue is sorted because of that binary heap mechanism I mentioned. And it's kind of sorted because the highest priority element is always removed. However, internally, it may not necessarily be sorted. We'll go into that a little later. So what are the core queue methods? The most important ones are the pole and the peak. So we'll talk about those first. So peak, it's kind of like what it sounds like. You're taking a peek at the front element, but you're not removing that element. Pole, on the other hand, you take a peek and you remove that element. So you're removing the element from the front. Offer is you add an element to the queue. So offer is basically the add method in the list interface. But with queue, you can actually still use the add method. It's just that the offer method is specific to the queue interface. Then, of course, there's the remove method, where just like in the list interface, you can remove an element. However, if the queue is empty, it will throw an exception. Element allows you to look at the element in front. So it's similar to poll, except that it throws an exception if it's empty. So in summary, the most important the most important method for a queue is poll and peak. Those are the ones you're going to use most often. Offer allows you to add elements to a queue, but you could actually just use the add method and it will do the same thing. So here's a live demo. So I'm going to start playing it a little bit. So in this demo, we have 3 documents. So it's kind of like a real life situation where you have an assembly line, you have a queue, and you have these documents on the queue. So in order, this document 1 is being inserted into the back of the queue first, followed by document 2, followed by document 3. And since it's a first in, first out, and this is a linked list, document 1 will come out first, followed by document 2, followed by document 3. When we're taking a peek, when we're looking at the first element, when we're looking at the head of the queue, you're going to see document 1. When we print, then it's going to print in order. Document 1, document 2, document 3. Now, PriorityQueue, on the other hand, we're adding a queue of numbers. So 5 will be added first, followed by 1, followed by 3. The difference is what comes out. So for number classes, the highest priority numbers are the ones lowest in value. So the one that's going to come out first is 1, followed by 3, followed by 5. And it's going to print in that order. So let's resume this. Okay. So document 1, 2, 3, 1, 3, 5, just like I said. So here, we want to demonstrate that a priority queue does not store elements in sorted order. I think I alluded to this when we were talking about that table. It does not store elements in sorted order. It only guarantees that the next removed element is the highest priority element. So we're back in our priority queue, and it looks like we already printed the output. So let me explain. So it's just like that last exercise. Okay. So you add these numbers in this particular order. However, when you print the object, the lowest priority object is in the front of the queue, in priority queue. However, the elements behind it could be in any order. Like these elements here, they're just in any order. And when you use the for each, it's going to come out in that order. However, if you remove using the poll, then they will be printed in order. Because what the poll method does is it removes elements from the front of the queue. And in priority queue, the element that's in the front of the queue is always the highest priority element. So before anything comes out of the queue, the elements are quote unquote reshuffled so that the highest priority element appears at the front of the queue. So here are the key takeaways. Lists, they store data. That's their priority. A queue is more concerned about processing data. Linked list works in a first in, first out method. Priority queue, it's the highest priority element, which is removed first. And in queues, we use the peek method to inspect and the poll method to process. So the poll method removes elements from the head of the queue. And of course, these lovely pictures would not be possible without the internet. Thank you and peace.